Today we're going to be learning about density. So in order to do this, you need to get ready to take your notes. In the assignment, you will notice that there are two things. There's a density note template or foldable. That is in the note assignment. You're going to fold them according to the video directions that are also under that assignment. In your table of contents, once you've done all the folding and printing, you're going to turn to the table of contents, write down the word density, and then turn to the next blank page of your notebook. This is where we're going to be gluing the notes at the end of the lecture. If you do not have a printer, just take a blank piece of paper, and you're going to just have to draw some of the pictures and fold it so that it matches our notes, and then tape it into your notebook. So what is density? So density is a measure of mass per volume. It's a word that we use to describe how much space an object or substance takes up in relationship to the amount of matter that an object or substance has. In a nutshell, it's how much stuff is in a given space. For example, if you were in a classroom and you had 5 people, and then you had the same classroom with 200 people, the room with 200 people would be more dense than the one with 5. In order to calculate density, we use a formula. We divide an object's mass by its volume. So the formula for density is mass divided by volume. A couple of years ago, I came across this. This is a density triangle. It's a really easy way to help you visualize what formula you need to use. So it's density equals mass divided by volume. The density starts here. We work our way around. Mass, volume. So then you have these two lines. This line means to divide. This line means to multiply. So if you were trying to solve for mass, it would be density times volume. If you were trying to solve for volume, it would be mass divided by density. It's just a really easy way to help you remember this. When we start talking about speed triangles and distance triangles and things like that, we tend to use this same kind of trick to figure out the formulas. So there are some standard units of measurement for density. So when we're talking about a solid, its unit is grams per cubic centimeter. When we're talking about liquids or gases, it's gas per milliliter. So if you remember back to the video we watched on the history of the metric system, you'll remember that a milliliter and a cubic centimeter are exactly the same things, except to measure liquids, we use the graduated cylinder, and to figure out volume for a solid, it's just length times width times height. So please pause the video and copy these notes into your composition notebook. So, all about density. So if you're going to find mass of an object, you're going to place it on the scale and record it in grams. We learned about that during our metric notes. If you want to find the volume of standard objects are going to be measured in cubic centimeters. And this is where that formula volume equals length times width times height. So the formula can either be written V equals L times W times H, or it can be written V equals LWH. Either way, length times width times height. We also learned about the water displacement method. And the water displacement method is where you put some water in a graduated cylinder, measure how much is there, put the object you want to figure out the volume for into the graduated cylinder, remeasure how much water is there, and you then subtract the first water level from the second water level, and that gives you the volume of your object. It essentially is how much water was displaced by that object. So again, pause the video and copy your notes into your composition notebook. Now you're going to go to the next foldable, set the other one aside, and find this foldable. So the density of water is 1 gram per mil. And in science, we often compare the density of an object to how it works or how it compares to water. So if you want to know if something floats or sinks, you need to know 2 things. 1, what's its density? And 2, is it greater than or less than the density of water? If it's less than 1, then it's going to float. If it's greater than 1, it's going to sink. Now, if it is 1, it's going to just kind of bob in the middle. Again, pause the video and copy the notes into your composition notebook. So, where can I observe density in nature? Is it something that's everywhere, or is it just something that Mrs. Baker is making me learn for the notes? Well, think about, have you lived in a house that has an upstairs and a downstairs? Maybe you have a main level and a basement. If you've ever slept in an upstairs bedroom, especially during summer, you probably noticed that the upper level is usually warmer than the lower level. Also, if you've ever been in a basement or the bottom floor of a house, it's much cooler than the upper floors. So what's the deal? I mean, does the air get warmer the closer you get to the sun? Is it magic? No, it's science. So have you ever heard someone explain that the higher temperatures are the result of hot air rising? They're absolutely correct. Hot air rises because gases expand as they heat up. When air heats up and expands, its density decreases. So the warmer, less dense air effectively floats on top of the colder, denser air. And when any substance is hot, its molecules are farther apart than when it's cold. This makes hot air less dense than cold air. Also, hot air has more energy, so its molecules are bouncing all over the place, versus cold, where they're close together. Think of it like on a hot day. When it's a hot day, you don't want to be around anyone. You're just moving as far away from the others as you can. When it's a cold day, everybody wants to kind of bunch up and keep warm. That bouncing around or not bouncing around, that's that energy. So then why do hot air balloons take off in the early morning? Well, the science we just talked about the hot air expanding and the cold air contracting and the hot air rising and the cold air sinking, this is the science that explains why we do that. The balloon catches the air that's being heated below. The hot air fills the balloon, and its buoyant force lifts the hot air balloon high up into the sky. As the heat sources dial down, the air cools, bringing the balloon back to the ground. We take off in the early morning because it's cooler and we don't have to heat up our balloons as much. So, what's the significance of air density? This system of hot air rising and cold air sinking, it's really what drives the Earth's energy. These air currents then that rise and fall of the different densities of air, the hot and cold, are what create storms, including hurricanes, tornadoes, our monsoons. Strong updrafts of warm air create cumulus clouds. And cumulus clouds look like those little floofy clouds. They usually have a flat base, and these clouds actually typically grow upwards. So you'll see that kind of anvil-shaped cumulonimbus cloud right before a big thunderstorm. These clouds grow into the thunderstorms, but then violent tornadoes are also associated with cumulus clouds as well as those microbursts as well. All right, it is note-taking time. Pause the video and copy your notes into your composition notebook. So wait a minute, why do boats float? Wait, I thought we were just talking about air. We were, but that same principle of density where less dense things float and more dense things sink have to do with boats. You can't walk on water, you'll sink like a stone, but this huge aircraft carrier can float even though it's over 1,000 feet long and at least 1,000,000 times heavier than you and carries 70 airplanes and 4,000 sailors. Ships and boats are really brilliant examples of how science can be put to work. The boat's mass is spread out over a large volume, and it's got a lot of empty spaces, right? So that means it has a large volume, and it's got it so its volume and mass makes its density less than 1. Or very close to a little under 1. So which means that sometimes it'll sink, you'll put more stuff in it and then the boat will go deeper into the water, but it's still floating. So how does it help an oil spill? So if you notice here, density helps clean up oil spills because the density of oil is 0.85 grams per cubic centimeters and the density of water is 1. Which means that the oil floats on top of the water and the water goes underneath the oil. So they use something called a boom to contain the oil, and then they can actually just skim the oil off. So pause the video and copy the notes into your composition notebook. Density even affects volcanoes. So we've learned that something hot is less dense, has more energy, right? Temperature basically tells you how much energy something has. So the sun, which is ridiculously hot, has a lot of energy versus something that's really cold, which has very little energy. Okay, so if something's hot, it's less dense, has more energy. If it's cold, it's more dense, less energy. So we have a volcano, and the magma is cooler and it's being heated by the Earth's core. As it's heated, it rises. And then lava erupts out of the volcano. This density, how it affects volcanoes, is something we're going to come back to later on this year because this drives our volcanoes, it drives our earthquakes, this idea of the hot air, the hot rising, and the cool sinking. So it's note-taking time again. Pause the video and copy your notes into your composition notebook. So let's practice density. If you would, get your third foldable, the one that looks like the calculator, and open it up. We're going to go through the questions together, and you're going to literally write all of this down. So before we begin, when you write it in your notes, and when you handwrite it and you have to turn it in, you write the formula, you plug in the numbers, you do the math, you don't forget units, no naked numbers. So the question is, a substance has 10 grams and a volume of 5 centimeters. Calculate density. So you're going to write the formula, plug in the numbers, do the math. I should see when I'm looking in your notes today that you have all 3 things written: the formula, the numbers, the math. A liquid has a volume of 4 mils and a mass of 24 grams. What's the density of the liquid? Write the formula, plug in the numbers, do the math. A large marble is dropped in a graduated cylinder with 35 mils of water in it. The water level increases to 49 mils. What's the volume of the marble? Well, the volume is your second water level minus your first water level. So 49 minus 35, and you get 14 mil. Again, I should see all three of those things on it. So a small small rock with a mass of 6 grams is dropped into a graduated cylinder with 20 mils of water. The water rises to 23 mils. What's the density? So we write the formula, we plug in the numbers, and we do the math. You will see on tonight's homework that you are going to have to solve for mass and for volume as well as for density. So which substance is going to float on water? Well, it's pretty simple. Which one is under 1? And that would be this one. So there is a error that a lot of people think that if something is liquid, it cannot be more dense than water, but that's not true. Take some syrup and pour it into some water, and you'll see that it sinks. So let's do our final practice on density. Write the formula, plug in the numbers, do the math. So now that you're done, you're going to take all of these, you're going to glue them into your notebook. So you'll notice that the density with mass volume is on the right-hand side. The density observed in objects is going to be glued to the left-hand side. You're going to turn the page, and then you're going to glue in the calculating density page. Make sure when you're done that you take a picture of your 3 notes and you turn them in. Have a good afternoon.